All right, cool. Well, then go ahead and take it away, Andres.
Okay, awesome. Let me share my screen. Okay, so to begin with, this has been a journey for me as part of several projects that includes search, which was like trying to find a way of teaching AI to anybody at any skill level with with any skill at programming, etc., etc. It's a program that we did with community college students. Then the Surya Foundation model and the Surya workshops that we have done to teach to use AI, you know, develop and implement AI pipelines in 1 week. And in a class that I'm giving right through the University of California, Berkeley right now, in a project that is called Butterfly, which is like it's a 12-week class where we take people with no experience on AI and we leverage very heavily AI assistants to do coffee science. So this is also part of the Coffee Science Center. And so this has been funded by NASA at, at all stages. So the HEATS program, the Office of the Chief Data Science Officer, and the Coffee Science Center. And we wrote a paper about this, my first paper in education that is now it has been submitted to the Journal of Computers and Education Open. So as you know me, I always start with a summary of my presentation. So the first thing is that AI assistants are a tool that is increasingly used in all aspects of human endeavor, certainly in science. And this is kind of like in this moment very unstructured and unregulated, every person for themselves. And this carries with it both opportunities and challenges. So it's literally a double, like the literal double-edged sword. Now, AI assistants are not semi-sentient entities, and I put a question marks here because it really feels like they are. And I often wonder if the way they work is very similar to the way we actually work, but it's hard to know. But they are subject to some of the same biases, they are subject to some of the same behaviors and characteristics. So, but I think that from the point of view of scientific use of AI assistants, I'm going to try to take everybody or try to take everybody away from the concept that they're sentient, okay? And rather to think about them as mathematical constructs that allow us to explore statistical relationships between concepts, given a training process that uses a vast corpus of text. Now, this idea that we're working with a statistical distribution, we're sampling a statistical distributions, in my opinion, is center point to the effective leverage of AI assistance for any purpose, but is especially important for scientific endeavors. Now, when you interact with these entities, this is the center point of our paper. We pose that conceptual vocabulary which is your understanding of the subject that you're working with the AI, not your prompting skill, is the primary bottleneck in human AI collaboration. So the quality of the human AI partnership is limited by the conceptual understanding of the human. So the same AI system in different hands produces very different output, even if they're all following the same prompting structure, okay? And one of the things that is very close to my heart, and I feel like it's a challenge that we need to face as a race, as a species, is that, you know, we need to account for the fact that our students are using AI almost indiscriminately. And so our educational experience need to reflect this. And what we pose is that they still need to be focused on building the learner's vocabulary and conceptual understanding as they have always been. So the most effective users of AI are the generation that was taught without AI, the generations that were taught without AI, right? And so, how do we then accept the fact that these systems exist in our classrooms, in our mentorships, in our, in our own journeys of self-teaching, self-guided learning, to kind of like truly refocus the whole experience in learning vocabulary and conceptual understanding. So let's start with the first part. The fact that just the statistics that demonstrate this, that it is a tool that is increasingly used in all aspects of human endeavor, but it brings challenge and opportunities. So, as you probably have seen in the past, specifically, and I choose this example because it's so close to us in science. AI adoption in software development is insane. So we are talking about more than 80% of developers use AI assistants. And I think that lately, this year, these numbers have increased around me significantly, also in my peers, in scientists around me. So, it's like, it's a reality. We're also using this to write, these entities to write. So as you can see, for computer science papers in arXiv, biomedical abstracts in PubMed, and in the Nature portfolio, there is like an increase of the use of AI. And so, it seems like the curve is tapering. I don't know. It's hard to extrapolate what is happening or what will happen in the future, but clearly, from the point where ChatGPT comes into the picture onwards, you have this clear behavior. Now, there is this concept that has always been a concern among users and people that see others use AI, and is the idea of cognitive surrender. When you accept what you're seeing as reasoning for the part of an AI system as your own logic. And so it's actually something that is really hard to overcome or avoid, but it's a reality. So when we think about, cognitive psychology describes human condition as composed to two types of thought processes. One that is the one that we use to process the overwhelming majority of information. That is, people refer to it as system one. It's fast, intuitive, and associative. So you, with very little information, come to a conclusion, take a decision, and move on. And then there is the idea of the system two, which is slow, reflective, rule-based, and effortful. So the system two is something that requires active effort, where you say, no, wait a minute, and like, did I actually see Matt Damon in, downtown Boulder? Like when you're like have this moment where you say, wait a minute, this doesn't add up, and you bring on a different engagement with cognition, that is like you start like analyzing things very like at a conscious level, etc., etc. But there is like really interesting, this paper is really interesting, that it says, well, AI is joining the cognitive exercise as an external system, which is artificial. And it's interesting because AI is also, quote unquote, a reasoning system. The fact that AI assistants are large language models, and they present language in what seems to be a very logical way, so we perceive them as reasoning. And so when we engage with them, we can accept their logic as ours. And so now you have a cognitive system that is external to yourself. And that's what we call cognitive surrender. So, and cognitive surrender is really hard to avoid. So if you do use AI, you will have noticed this. You ask the machine to write a code for you, And then when the code comes back, there is a small detail that needs to be changed. And I personally sometimes struggle. It's like, no, change the title, like something, maybe that example is a little too trivial, but sometimes you kind of like take your assistant and have it fix something in a plot or something in the documentation that actually will have taken you almost no effort. And so that to me is what I identify as my own cognitive surrender. So AI assistants are not semi-sentient entities, but they are means by which we explore the statistical relationships between concepts. So I'm going to start by talking about large language models and how they work, okay, and why they are so revolutionary. So when you think about language, and that this is why I put the question mark on whether they're sentient or not. So language, the exercise of language is an exercise of probabilities. We like half of the effort of understanding a text or speech is guessing what the next words or the next sentence or the next things on the text are actually going to be. And so, especially like if we're in noisy environments or if there is with many people, and this happens a lot, a person starts making a statement, and before they're done, we kind of already think we know what they're going to say. So there is this aspect of to streamline and speed up communication between ourselves. We guess what the other person. We have a context. We know what we're talking about. We're talking about coffee. So when the person is thinking about grinding, is going to say something about grinding, we're kind of guessing already that this has to do with the beans, etc., etc. But if we were in a disco and we were dancing or something like that, this concept of grinding will be very different. And so when you have a sentence like this, France is my home, I speak fluent blank, there are multiple words that could go here, right? And there is one word that probably is screaming in your mind. You know, this language, this language, this language. But there is more than one language in France. It could be a different language. There is but nevertheless, you have a very clear idea of what the next word is. So when you bring one of these machines to do this, you have to turn this into a vector that can be operated mathematically on. So the first thing that we do is we codify the words in tokens. So we give each different word a token. This is a little simplistic. Question marks, punctuation are tokens. Sometimes partial, like complete words that are like close up. Close up can be a token. Even though close can be a token, up can be a token. So these kinds of things are tokens are not the perfect map between words and numbers, but they're close. So you tokenize this. So in France, always have the exact same code. Like always is predictable. France is always going to be 153, always. Then we do something that is called positional encoding, which is append to the sentence, to the word, to the text, information about where the word is in the whole context of the conversation. And because these machines work with very, very long chains of context, hundreds of thousands. So you have this positional encoding tends to be pretty sophisticated. It's not just 0, 1, 2, 3 to 100,000, but people use like Fourier projections to encode where things are in the window. And then you bring online something that is called multi-head attention. And this was what was revolutionary in this technology. So multi-head attention is, before the arrival of the transformer, we were using one-dimensional relationships or two-dimensional but limited field of view relationships in our architectures, convolutional neural networks, multi-layer perceptrons, these kinds of things. But the multi-head attention is a matrix relationship. Every single word of your window with every single word in your window. So is, if you have 100,000, you're talking about 100,000 square. That this is not strictly speaking true. There are limited form of attention that are used to manage, relationships, etc. But in a sense, the idea of the of attention is a matrix relationship that is independent of position. And there are multiple layers of matrices that you stack so that you can have a matrix that is dealing with one kind of relationship, another matrix that is dealing with another relationship. And so, for example, if you say the word France that I highlighted as red, France is related to different words in this sentence in different contexts. So if you say France is my as the most dominant, connection, home, and I, that is speaking about a relationship of belonging, it's your country, you're kind of like there. But if you connect France just with home, you can, as home with this, as so home being the salient point, then you are talking about more like a location. And if you say France with speaking, right? Then you are talking about a concept of the geography of language. And so multi-head attention is a means by which the machine can create its own dictionary of connections between words. And it has different aspects, etc. But this is what was revolutionary. Now, you put a bunch of these layers on top of each other and add normalizations, etc. And the other thing that you have is that your inputs and your outputs get concatenated. And now the machine has the ability to influence itself. So what was an output becomes an input. You shift it. And now becomes part of this determination of attention. And as you move through the architecture, you eventually end up with what looks like a set of probabilities, so a distribution. And this distribution has the size of your token space. So for Claude, AI is 100,000 tokens. For Gemini, I think it's 250,000 tokens. For ChatGPT is 200,000 tokens. These tokens actually include all the tokens of the English language plus all the tokens of the Spanish language so every language is included in the token, in the tokenization. There is a unique token, even though car may exist, the concept of car may exist in multiple languages, in each language gets its own token. And so you have like a probability that the next word can be any word in any language. I mean, as defined by your token space, right? Like not absolutely every language is represented, but the most spoken languages are all represented. And then you take that distribution and randomly take one out. So there is a series of steps that you do to massage that distribution, and there is logic, there is reason, and there is intentionality on it. You eliminate the tokens that are most unlikely and reweight your probabilities, etc. And there are strategies, there are benefits to do this in certain ways. But at the end, you take one word at random and put it there. And the level of randomness is controllable. So there are several pathways by which you can broaden or narrow that distribution. So one of them you may have heard is called temperature. You can control it in some of the AI assistants that are commercial. And so you tolerate a wider range of possibilities to get access to what people call quote unquote creativity, the ability of the machine to jump farther from the topic that you're exploring and things like this. So What is really mind-blowing about this technology is that it's the ultimate exercise in conditional probability, and is doing conditional probability at a level that is just so uncanny as to seem magical. Okay? Because every single one of your AI assistants, if you have ever interacted with one, all it's doing is randomly drawing words. It's absolutely insane. You draw a word, you use that to do conditional probability, and then you draw another word completely at random, but that random from a distribution that is conditional. So what came before, what you have said, what the machine has said, what how you have responded, blah blah blah, etc. I'll talk about some of these things in a moment. They all condition your probability, and then you take words at random. Like when you are interacting with an AI system, it's a random process. There is no logic. There is no logic to it. It's all conditional probability. The logic is built in the probabilistic connection between words given a context, and that is like absolutely insane. Now, I wonder if actually we work that way. The more I feel like I understand this concept, I wonder, man, like maybe we actually do work like this. But one of the tokens that I find most fascinating is the EOS token, which you may know is the end of sequence. So if you have ever wondered how does one of these AI assistants decide that it's done giving you an answer, it's completely random. So during training, the machines get exposed to the concept of paragraphs and of certain duration of what is an acceptable duration for an answer, etc., etc. So as you in the context window, you put more and more words, and the machine puts more and more words itself, then eventually the end of token comes out, and the machine stops putting like things on your screen and handles the control back to your window. And it's absolutely crazy to me to think that this is a random process. Like there is no algorithmic decision behind any of these things. So if you think about the prompt, what are the most spoken language in the United States? And then what's the next word going to be? You can think, which words can they be, right? And to make the example, I was thinking, okay, let's just come up with some of them, right? It could be the, right? The could be. What is the most spoken language in the United States? The most spoken language in the United States. It could be besides. Besides English, the most spoken language in the United States is Spanish. Or it could be most. Most of the people in the United States speak English, but there are other languages that are spoken in communities that are smaller than, and always you have the end of file, I put end of file, but it was end of sequence. So you draw one and you get the, right? So, the cannot be, you will not have two thus, one after the other, the zero, The besides also cannot be, but it could be the most spoken. It could be the English language is the most spoken. So that's kind of like how this looks like. But this is working with a level of sophistication and finesse and complexity that is just incomprehensible for a human being. The crazy thing is that if you say, what are the most spoken languages in the United States? Be brief, right? Like that statement significantly increases the chances that you're going to get your end of file token, end of sequence. And so that's kind of like the wild thing about these things. They're completely random and still they're useful. Still they are kind of like mostly factual or correct. It's absolutely crazy. Now, the context window determines how many tokens and words can be used to condition the distribution. So this is a different number. The number of unique tokens per Claude is 100,000, including all the languages. But the number of tokens that can exist in a context window and condition your probabilities can be in the millions. So it's like, and so you can imagine, like, you can already kind of like, it's almost a mind-blowingly large number for us to comprehend about the different possibilities and combinations. Now, there is this really cool concept, which I think is like at the core of this, that is called conceptual, I'm calling a conceptual adjacency, right? Imagine that every single, like a particular distribution of possibilities is a vector in a multidimensional space, right? So you're having a conversation with your AI assistant, and after the prompt that you placed, there is a possibility of all the words that it can answer you, okay? That vector is pretty unique. It's basically like every conversation and interaction ends up having almost like unique identifiers, right? And if you project them into a space, which, because we are limited to 2 dimensions for this kind of communication, I'm going to put in 2 dimensions, but imagine that this is 100,000 dimensions, because we have 100,000 tokens in Claude. So every single distribution can be mapped to a single point in 100 dimensions, right? So these spaces have structure, because words don't just randomly and uniformly lead into each other. There is going to be like lots of points, less points, and there is going to be a structure to this space, right? So when you get an answer from your AI assistant, you're traveling through this space. So it's a word that appears like, it's probably one of the most common words in the English language, right? So there are a bazillion possibilities about how the can resolve, right? It depends. It like, so the cloud associated with the is it has a lot of points, because every single one of these points will lead to a different word, or will have a different possibilities of distributions that will lead to car, right? So you go into another cloud, you move into you draw a random word out of the possibilities, and the random word is car. So you move into that part of the space, and there are distributions of points, distributions associated with the concept of car. Now, car it's not as common a word, so it doesn't map well into a lot of different things. But it will map to a huge amount of verbs, right? Is, runs, uses, that kind of stuff. So things can be so many things. So you have this cloud here where is like, again, I think red, and then red is like, how many things can go after red, right? Like red, especially if you're in English, maybe you could say beet red, dark red, these kinds of things. But red is going to end up, very likely is going to go to a punctuation mark or something like this. And so there are these trajectories that exist in these spaces, and a sane AI assistant moves predictably. It moves between here, this. And depending on your temperature, you could take trajectories that take you in completely different ways and different directions. But this is one of the things that is kind of powerful about this and useful. That's why you can say, hey, I want you to help me write a code that uses Markov-Chain Monte Carlo to estimate coronal heating in coronal loops. And maybe even if you're the first person in the universe that has ever applied Markov-Chain Monte Carlo to coronal loops, these chains allow you to migrate and map into spaces that in the human knowledge are disjoint. And so that is kind of like the powerful thing. And that's why these things end up being so useful. Now, the idea that you're sampling this distribution, I think, is critical for the effective use of these assistants for any purpose, but especially important for scientific endeavors. And so the first thing that I wanted you to think as users is what defines these distributions? What makes that end of sequence token more or less likely? What makes the possibility that this is going to go into a very succinct list of languages, or is going to tell me which percentage of the population of the United States speak every single one of the top 10 languages, right? Like there is, all these are possibilities, and this is going to be conditioned. So when you use a, a model that has been trained, you're given already a space with likely trajectories, right? So when you use these entities, it is to our advantage to understand a little bit how these distributions come to be, because what we're actually doing is conditioning distributions. So this is that what we do when we interact with an artificial intelligence assistant is condition the distribution, play with odds. Through our expression, we change our odds. And so understanding these distributions and how they operate is to our advantage. So obviously, the dominant thing is the training set. Corpus of written text used during pre-training, the quality of it, how factual it is, how well it covers the entire body of human literature. Is there a particularly, is law overrepresented? Is heliophysics underrepresented? You know, does it have a lot of experience with coding or not, etc., etc. This is not something any of us really has access to know for sure, but it is one of the things that is most different that makes a difference between Gemini, ChatGPT, etc., etc. And then the fine-tuning process. Every single one of these entities is trained using something called reinforcement learning from human feedback. So people get an answer and they say, I like this answer. It's a good answer. No, this is a bad answer. And this is used to massage the probabilities. So if the people, whoever they were, we don't have a clue who they were, are they mainly like a demographic? Are they mainly over 50? Are they mainly in their 40s? Are they mainly in the United States? There is a cultural context in which what is an acceptable answer from one of these entities that is cultural. I like this. If it's American, politeness is going to be absolutely central to these machines giving a quote unquote useful answer. And how well do the humans know the subject that they're being rating? So are they experts? Do they know about coronal heating when they say, yeah, this was a useful answer? So these are things that are also part of these odds that you don't have control, but exist. They're there. The other thing then is operators instructions. So every single interaction that you have with one of these systems has prepended a set of instructions that includes guardrails, includes operational instructions, etc., etc. You don't see them. You don't know what they are. They're proprietary. And so these are what prevents you from trying to use these things to plan an attack or these kinds of things, or use it, in inappropriate ways. But it also includes a lot of different instructions to make them more useful, more factual, to get your odds to get those odds in your favor. Then your user's instructions, you can define a set of instructions that apply to every single one of your prompts. And so that will change your odds. The language that you use, the instructions that you do, the order in which you put them, change your odds. And then your initial prompt. The initial prompt tends to be pretty important. The closer you are to the beginning of the context window, the more important things are. But you also are affected by what the large language model is answering itself. So that also changes your odds. and your responses. So all these things change odds, and when you work with these assistants, you have to always remind yourself that you're gambling. That's what you're doing. And your agency comes in the form of language, how you express yourself, what are the things that you do, how do you emphasize things, the order in which you give them, etc., etc. So using a large language model is always a gamble, always a gamble. You are playing with chance because that is how they are designed, how they work, right? So, which is wild because it's easy to lose touch with that the fact that you're dealing with a noisy random system. You know, there are many events in our lives that happen only once and create the illusion that there is no noise and randomness, but there is. We could have not gone to that university and never met the person we're married with today, right? But we don't have a clue. Now that the chain of probabilities has collapsed, our lives in retrospective have a clear narrative. This happens because I was there, because I was sick, I didn't go that day, because and I missed and my grades were not that good, so I didn't get my internship. So I had to go to this university where I met the most amazing advisor. So these things are true when you interact with a machine. There is a chain of responses that log probabilities in a way that you're unaware of. If you just create a completely different window incognito, ask exactly the same question, you will map not necessarily a completely different trajectory, but a noticeably different trajectory in that random space. So one of the things that I think is a huge LLMs cannot be trained to be factual. Cannot. They are not trained to be factual, will never be trained to be factual because they are random systems. They are trained to be coherent and perceptually useful. That's what they're trained to do. Now, there is a connection, and that's what it makes them remarkable, between factuality in terms of odds and usefulness. So, but, to think that you have this thing that is lying to you, is not. No, you play your dice, you roll your dice, you get your odds, and you get something that is not factual because it happens. You took a gamble and it didn't work. They inherit real biases from their training. So there is the idea of the corpus bias, what I was talking before. So I know how this was trained, etc., etc. Your training window. There is this really weird thing that happens when because the quote unquote useful, the reinforced learning by humans tends to be executed on shorter answers. When you use a context window for a long time, actually. So it's better actually to not use the same window for a long time, but do what you need to do, let it be. And if you need to have another conversation on the same topic, just create another window, start from scratch. Because the majority of text in a training window is AI generated, is random. And that conditions your odds. So the more you spend time in a window, the more those odds are determined by randomness and not by you. So, you have like this is how they work. Source material veracity and density, if there are no papers about quantum electrodynamics applied to solar physics, and there is not a lot of papers about electrodynamics, quantum electrodynamics, then you have a coverage problem. And language bias, the models that are produced and marketed and commercialized in the United States are made by Americans. So English is the dominant language of the developers and the language and the models themselves. And then of course you have the human bias that the raters lack diversity. I mentioned that, and the idea of psychopathy. sycophancy. The idea that we tend to consider a good answer something that agrees with us, is agreeable. Not a lot of people have a quote unquote fight with the machine and then rate the answer. Yeah, this was a good answer. And so this is something that the operators actively try to manage, but it's a reality. Wonderful. It's a very culturally American, and like when you see them, it's like, yeah, that's great. That's a great idea, but that's kind of like the way people kind of like exchange ideas here. But I will say it's a gamble that is almost always worth taking. So as long as you understand that it's a gamble, it's always worth taking, because they can be conditioned to be highly likely correct. So there are a series of systems that can be implemented by you or are implemented by the operators to stack the odds in your favor. One of them is retrieval augmented generation. When you say, do a web search about how people play or win in Fortnite, what are the strategies for playing like and winning in Fortnite? And so the machine goes online, finds 12 like web pages, and then uses that to anchor its odds. And so that helps. You can do a deep research, like for example, all these commercial assistants can go into a deep research where they actually go online and look at the papers and look at the citations of those papers and try to do a very deep search and then give you a summary. So you can then take that summary and use it as a context in another window, and that is retrieval augmented generation. This conditions the odds in your favor. The other things are chain of thought tokens and chain of thought prompting. I don't know if you have noticed, if you use AI assistants, that they think out loud. It says like, oh, now I'm going to check whether this code returns an error. Or now I'm going to check and make sure that the module exists in the environment. You see that in real time. It's actually fascinating. The wild thing is that these chains of thought tokens are just for conditioning your odds. The machine is not checking this. It's not checking whether the error, the module exists in the environment. Well, sometimes when it becomes agentic, it does, actually. Sometimes there is the randomization of this process leads to agentic decisions where it asks you for permission to check your environment and add this to your context window. But when it's doing something like reconciling coronal heating models, like these kind of statements are just to condition odds, which is wild. And people have found empirically that just putting this sentence inside the context window makes things better. And you do the same. You say, I want to plan a class about the solar cycle. And, I'm thinking about talking first about this, then about this, then about that, and then about this. You make a list of things. When you do these kinds of prompting, you also get better results. And of course, nothing beats human expertise. There is nobody can get nothing more amazing from AI than an expert. A person that really understands their thing can get these machines and condition them to hum and to give you like insane things. So, that is, I think, the center point of what we want to accomplish. Now, one thing that I also think is wild and puts all our odds in our favor is that large language models are inheriting the logical machinery of the human language, which is actually mind-blowing. Like, only with 15,000 tokens, we can articulate complex thought about any topic and build knowledge. It's like absolutely insane. But that is built into all these distributions and conditional distributions. And so we can count on that. And second, the wisdom of the crowd. So humanity does create aspirationally truthful content. And the odds are in our favor because humans are good humans. And so that is also in your favors. So failure modes for scientists. Out of distribution generation. A machine cannot put two words together that have not been put together before in a text. Okay? So if nobody has thought about putting concepts together before and putting them in paper, the machine cannot do it for you. And that is a challenge as a scientist because we are, by definition, or at least aspirationally, strive to be out of distribution. So we're trying to create new knowledge, different new ways of putting concepts together. So that is a limitation that we need to be aware of. Poor representation in training data. Again, we are very technical and very specialized, and we hyper specialize during our careers. Well, that's not true. During parts of our careers, and then we can go into an adjacent field or a different field and hyper specialize again. But this is not so super well represented in data, so there's a limitation. And this causes a problem that I think is hard to be aware of, but it's a reality. When you are in a poorly sampled part of these trajectories, you have noisy probabilistic chains. You don't see them because you only talk about coronal heating once with the machine. You only ask the question once and you get one answer until you're satisfied or need to do something else. But if you will do this every day, ask about coronal heating every single day, you will be cognizant of the noise on the trajectories. And again, exposure bias. Long conversations tend to consist mainly of generated tokens. And when you're in poorly sampled parts of the distribution space, that's bad because the machine degrades. The probabilistic connection between words can degrade, and you may start getting more random things. And eventually, a completely broken model, like jailbreaking models, is people trying to get the machine conditioned in a way that takes them into very unlikely spaces. And so the machine becomes erratically, becomes psychotic. These kinds of things that happen to humans as well are basically the model running in trajectories of very broad distributions where anything becomes possible. But coding, I don't think these machines are just almost like they were not really invented for language but for coding. Coding is such a optimal environment for probabilistic exercise because it's also self-reinforced. These machines can run code, get errors, see the errors, and contextualize those errors so that they fix them. And so coding is insane. Especially if you're a good coder, this is almost like it's almost like as an spiritual experience. It's crazy. New applications of well-established techniques. So in astrophysics, people are really, really, really good at Bayesian statistics, but in heliophysics, we are not. And so when you have a huge body of literature about Bayesian statistics and you want to apply it to heliophysics on a problem that is generally well understood in heliophysics, you're in business because these machines can really, really bridge the gap. And there are these models that are creative, and if you don't mind and you're aware that this thing is going to be a little erratic and you're not really in the business of getting something completely factual out of it, you're exploring possibilities, then you as a scientist could accept high temperatures, more randomness, and maybe see if that some of the things that the machine exposed you to trigger ideas. And so, Now, to the last part, moving here is, our premise that conceptual vocabulary, not prompting skill, is the primary bottleneck in this collaboration, right? So if you have if it's clear in your mind, if you could do it yourself, you're going to get an insane thing out. If you're very vague on it, you're going to get something, but that something may not be very good. And so maybe the odds are in your favor. Now, if you go into this like prompt, how do I do this? How do I get the best outcome of AI? Then probably you will have seen this. It's like the first thing is be specific. And I have always thought this like is ridiculously stupid advice, because this is advice that is only useful for those people that can be specific. But the overwhelming majority of users cannot. And in fact, me as a scientist, some of the most interesting exchanges that I have had in the last month with my assistant is me learning things that I don't know. And so I cannot be specific about reverse diffusion if I don't understand it. And so be specific is like whatever, It's like a marathon runner giving you advice that only works for a marathon runner. So to me, the mind-blowing experience about this was last year when I started exploring how people in the semi-amateur world do image generation. So these are people that actually use models, use LoRa's, load weights, use GPUs, and have like a visual programming language around image generation. So this is not like ChatGPT do this, but it's people that actually trade, Mid Journey for flocks, or they are very like highly technical. And I was looking at images that had the whole pipeline of generation, prompts, LoRa's, models, checkpoints, tokenizers, all these things inside the image. There are communities that do this. This image has the whole framework in the metadata. And I opened this one, and the prompt blew me away. So I'm going to show you the prompt. I'm going to go to the prompt relatively quick, okay? I'm going to give you like seconds to read it. But the prompt that produced this image is this one. I was like, okay, I'm done with this. I'm like, my, I like, I was like, I was so in awe. I was just so in awe that there could be a human that make a prompt like that. The concepts, every single concept about lining, the highlights, the background, the textures, the colors, the mood, the composition, like all these things. Many of these concepts, it was the very first time in my life that I have been exposed to a concept like that. And then I was like, that is being specific, okay? How many users can be that specific? Like how many of the people that are generating images today can be that specific or are this specific? Obviously, the best AI generated art can be only generated by the best artists, period. And so this what brings us to this concept that we're trying to formalize of the AI collaboration scale. So when you engage with an AI assistant, you are going to land somewhere in this scale. On the one hand, you have what we call creative subordination. So you are very vague, your understanding is very limited, your vocabulary is basically day-to-day vocabulary, and you don't have any way of knowing what the machine is giving you is good. Except that maybe it looks okay or it seems to work, right? Then there is surface checking. You can spot the most like salient errors, but you don't have the terminology to evaluate any deeper choices. Then there is active direction. You can decompose the tasks. So now you can see how in this collaboration scale, your conceptual understanding and your vocabulary allows you to progressively become more and more specific. So, decomposing tasks, identifying wrong approaches, etc., etc. Critical collaboration, you can be a technical peer, maybe an expert in solar cycle that is looking at a proposal in coronal heating, right? So you identify a lot of things now, or maybe not even coronal heating, but helioseismology, pretty even closer. And then obviously equal partnership, where you have complete agency and you distinguish whether what the machine is giving you is better or different, or if there is an even better way of doing things that the machine didn't give you in this roll of the dice. And so as users, we need to strive towards equal partnership. And that means that we have to actively work towards learning and using vocabulary, which is really hard. That's not how we read text normally. We read diagonally, it kind of makes sense. So it's a very difficult and effortful task, but it is the only way to really elevate what you get out of AI. And so what we're saying is that in the context of a classroom where everybody has an AI assistant, the focus of building learners' vocabulary is more important than ever. But luckily, the AI can help, not without a solid foundation, but it can help. So the idea is that the idea that we're exploring is the idea of these comprehension and vocabulary thresholds. So people have found that to achieve full comprehension of a text, you need to understand more than 95% of the words. When you understand more than 95% of the words, you can use all the words around the words that you don't know to understand what the other words mean, basically. So you now have full comprehension. Anything else lower than this, and now you start missing words that you will skip, but you don't have full clarity on what that context meant, okay? But there is also evidence that vocabulary grows exponentially. So there is a threshold above which, through sheer exposure, you can grow vocabulary, and this growth is exponential. So you're like in business, you just have to work. And once you do the work, you eventually get to the 95%. So what we say is that domain vocabulary coverage likely affects where you land in the collaboration scale. And by the way, this is domain specific. You can be an expert in heliophysics and a very poor COBOL programmer, right? So no matter how rich your general vocabulary is, domain specific vocabulary will limit your ability to get good outcomes. So the idea is that we have to broaden conceptual vocabulary. So what we're proposing is that once you cross the threshold, and you're in the exponential growth part, you can actually leverage AI to build vocabulary. So you prompt at whichever level you are. So that's kind of like the first step. Then the machine has directives to assess your level and introduce terms you don't know and highlight them and force you to use them. So you start acquiring vocabulary that you don't know through the interaction with your AI assistant, which you can then use to express yourself better, write better prompts, more precise requests, etc., and start this loop again. So that is the opportunity that we see when we use AI in education, AI assistants in education, both formal, informal, at all levels, not at all levels. I think that there is a school level, I don't know, maybe middle school, where probably people should be focusing on building vocabulary the classic way. So you need to get to the threshold before you can get into this loop. So, but once you're in this loop, college students, graduate students, postdocs, and professionals can get there. The powerful thing is that LLMs are trained to be conditioned by language. So in our empirical tests, we see, I applied this to my daughter, and I had my daughter interact with it, 8th grade level language. The machine very immediately was conditioned to talk to her. But when I use the same framework on myself, and I use distributions and marginal distributions and conditional probability, the machine speaks to me at my level. But the challenge is that because machines are optimized to give you quote unquote useful answers, that has the unintended consequence that the machines tend to be trained to fill the gaps silently. So if you have missing concepts, the machine will silently match them to the most likely thing. And oftentimes that is correct. And so you don't get necessarily exposed to this loop when you get an AI assistant out of the batch. So when we design educational experience, we're saying that when you design a class in which AI assistants are an integral component, you need to first start by priming the vocabulary of your students or your mentees. So this is true if you have an REU student, okay? And then you need to make sure that as the person gains vocabulary, it gains vocabulary also in the domain. So not only enriching the vocabulary in general sense, but in the domain. And then you should provide the prompts to your students so that they know how to prompt around the concept. So you model the prompting behavior, and when you expose them on unleash the AI assistants, you model the behavior and give them the prompts that they should use to interact with the assistant. And then tasks the machine inside your prompts, tasks the machine to challenging your students or challenging yourself. I'm going to expose you to this in a sec. So that you're forced to use the vocabulary that you're learning in the hopes that you really learn it, right? And expose everybody involved to this idea that there is a scale of collaboration that they can aspire to increase the level of collaboration that they're in. And I have been using this, I think, it has been fascinating to using it myself. To really learn now and feel like I am finally understanding reverse diffusion or exactly how large language models do work so that I can present them to you. I have done Bayesian statistics. I have used it for a lot of things that I find very useful. So we have a set of prompts to enable this dialogic bootstrap cycle. And I was hoping that maybe you guys are interested on trying them out, okay? So your mileage is going to depend on the LLM and the human AI interaction. I have found my best mileage if I keep it to me trying to understand a concept more than me implementing a code. When I implement a code, the context window gets filled with code, and the internal reasoning of the machine is all internal coding and outputs and looking at your files and things like that. So very quickly, your context window gets full of things that completely destroy the thing. So I have found it the most. I have tried, in principle, I have tried to use it to build something, but the degradation is super fast. So depending on how this works, you will get a certain amount of degradation. But if you really focus, conceptual understanding is pretty interesting. So I'll say it's experimental, but promising. I have used it with the undergraduates, I have used it with graduates, I have used it on myself, on my daughter. We have used it in Spanish. We have a version in Spanish. But obviously, we need help testing them and improving them. So anyway, this is the whole presentation. And what I wanted to do now is basically give you a quick tutorial so that you could get a conversation started with these prompts. And maybe later, next time we meet, you tell me, whether you found it interesting, useful, what worked, what didn't, etc., etc. But before I do that, I don't know if you guys have any questions about anything that I have said.
Hey, yeah, thanks for that very much. I've been following along at the edge of my seat here and just opened up that GitHub repo, and I'll be taking a look at this, certainly.
Okay, let me show you really quick how this works. So, okay, so here there is going to be two prompts, one in English, one in Spanish. And if you open the one in English, you're going to see it like this. Now, this prompt exists in Markdown language, which Claude understands. So the best way, I don't have like a lot of, I kind of tended to do it this way, is I actually open it raw. So when I open it raw, I get all the Markdown tokens. And so that adds an additional layer of structure to the conditioning. Now, the prompt has something for humans, which exists at the top, and the rest is for the machine. So what you will do is you copy this into a text file. I recommend the session length to be 60 minutes. I found that giving a session length stacked your odds such that the machine gives you closures. If you don't give a session length, the machine will think that you're going to be talking with the machine. Well, not think, but your odds are such that it seems like you're going to be talking for this for the rest of the life. And so you put a session length, 60 minutes, I might recommend it, default. And then the topic. The topic is a sentence, reverse diffusion, Bayesian statistics, etc., etc. Now, we're giving this, I found the most useful to just understand a concept or explore a topic broadly, not so much get a task done, but you could test and see and tell me. And then there is an optional session context. This, I designed it mainly for educators. So when you, and like if you have an undergrad student this summer, this is one of the things where you could put things. So the primary domain is solar physics. The adjacent domain is a statistical modeling or Python or, So this is a way in which you can stack the odds in the favor of your mentee or of yourself. I actually do it for myself. This primary domain and adjacent domain, typically I feel. Now, these two are meant for the educators, and I don't use it even in my classes yet completely. But the idea is that you can also frame the vocabulary that you already learned so that you don't learn it again. Because when you do a new context window, it's going to start from scratch. So you could do that. And you could use your machine to fill this. You can say, hey, give me a comma-separated list of the vocabulary that I learned this session. So it gives you a comma-separated list and you paste it here. Next time you expand it. And the target collaboration level, but I find maybe I eventually will take this out. So you put this in and then you take your AI assistant and you give it a little blurb. So let me see, for example, understanding AI reasoning and language model architecture. So I said, I want to understand how AI assistants like Claude work and reason. I have a general understanding of the large language model architecture, but I'm not sure about the statistics and the reasoning component. Let's start with a basic explanation and use the attached instructions as imperative. So when you paste these things in Claude, they get attached more like, even if you copy and paste, they get attached almost like a file. But it may be different in different assistants. And so it starts, great topic, that's a well-engineered session framework. Yeah, woo! But it will say, okay, a quick heads up how this session will work. It will work through conversation. I will bold concepts. And before I move on, I will ask you things. And, how is the best way you learn? This was actually a suggestion by my daughter. So you answer and it goes. And it's pretty interesting. Now it's effortful. It will make you work for your output. It will ask you questions. It will ask you to reframe them. It's not the traditional AI interaction, but it is really worthwhile. And I feel that in a world where AI use is widespread, to think about these things, to leverage these prompts and refine them, etc., gives us a competitive advantage. And so you're writing a proposal. You can say, write me a proposal about coronal heating, but you're better served having a full conversation about coronal heating, how people do it, what are the concepts, etc. You know, Summarize this, open another window. Now that you understand better, this is the dialogical bootstrapping. You understand better, and you say, okay, now that I understand better coronal heating, I want to understand. You open another window, start fresh, another prompt. You now have a better idea of your topic, your domain, and your adjacent domains. And then you frame this thing differently. I am an expert in Bayesian modeling, and I want to create a model of coronal loop heating that helps us discriminate between constant heating and injection on food points or top. These are things that you will have learned in the previous interaction. And so anyway, that's all I had for you guys. Thank you so much for your attention.
We have just a few minutes left here on the amount of time we had put in the agenda for this talk. We had it scheduled up until 20 past the hour. I am seeing one quick question that was in the chat. If you could look at that and answer it real quick.
Yes, not me, but my students have. And I have seen conversations shared with me, and I have seen ChatGPT. I have not seen Gemini yet. ChatGPT does bold, and it seems to work. So, but if you guys have different, one kind of like anecdotal thing regarding Claude, though, I kind of find, I don't know why, but I find perceptually that I prefer Sonnet, which is supposed to be the less competent model, to do this than Opus. And I suspect that Opus is so focused on the quality of the output and is very action oriented that it limits a little bit the ability of exploring concepts and exposing you to concepts. But if you do want to try this with Opus, and tell me, I think if you agree. But I have been tending to favoring Sonnet lately for this kind of a conceptual exploration.
Yeah, really nice. And maybe a follow-up question or a clarification on this regards is that you are using a paid version of Claude because it may be, I'm always wondering if the results are like significantly different if you use like a free version of the chat uh to a paid version. So
Yeah, so you just made me curious. I
mhm.
can choose Haiku. Haiku is for sure accessible for free in I have done Opus. I was like, oh yeah, let's work with the most expensive, biggest, bestest, baddest model. I have worked with Sonnet with extended logic, and I favor Sonnet with extended logic right now, but I have not tried Haiku or Haiku with extended. Now, um,
Yeah.
I think that you know, my students engage, a lot of my students this semester engaged it with free versions. But I need, and I did surveys, and they seem to be satisfied, but satisfaction is kind of like a landmark of training. And so it's hard to know for sure. I will have to do the experiment myself. But if you try this in a free version and you feel limitation, let me know. I would love to know. I think that is one of the things that is my dream, is that this prompt works on any model so that any person can use it regardless of their means and their preference. But I have not had the chance to really test it myself in different models.
Yeah, and thank you for bringing this because I think that heliophysics community needs to start digging deeper in the use of AI agents for science because I have seen a lot of like new results. For example, in high energy physics, there are some like recent written papers using Claude, and also in mathematics now there's like a boom of discovery of new theorems and proofs using ChatGPT and other tools for formalization. So I think that is a step that we need to take.
I, I think I think that there is an incredible amount of value on something that can do conditional probability with this degree of sophistication. And and so I think that demystifying a little bit the tool, and allowing yourself to explore it, understanding the limitations, I think it's really important. That's one of my objectives. I agree with you. I think there are a lot of interesting results in heliophysics that are waiting to be made in partnership. But the partnership necessitates sophisticated users, competent, articulate, and nuanced. And that is both in AI and in heliophysics, etc., etc. And I think, one of the things that I want to finish with is that I feel like we have a responsibility to try to advance and leverage this to ensure that the new generation can become sophisticated, nuanced, and articulate. Because, then, yeah, we can have a boom of a generation of people that were trained, lived like, Gen X, millennials, and Gen Z, all trained before these things came along. We do incredible things with them, and then we all die. And then, so I think that is the other thing that I would like to finish, that I'm hoping that, you guys think about this and see, how can we ensure that this knowledge gets PH, PyHC chart. Okay, let me then give you the floor and you plug it.
Oh no, I don't need to plug it just because we were talking about let's all adopt more AI and heliophysics. I've certainly been doing that, and there's the tool I'm doing it with. That's all I'm gonna say.
Thank you so much, friends.
Thank you, Andres.
You are the first people. You gave me my voice, so thank you.
I'm so
You're
glad
the
we
first
could give
people
this
that hear
platform.
this.
Whoa. Well, maybe I'll be lucky and hear another iteration with our RAU students this summer. Do
You
we have
also
any?
now understand the context, I think, yeah, I can, this was geared towards scientists, but I think I can create a version for students and mentors. I think that the mentors should be aware, because the student mentorship, the student mentor relationship is in danger, I think. You now have a mentor that tells the student, oh, let's do this. And the student goes and puts it into a large language model with a very limited understanding, gets something that doesn't work so well, goes back to the mentor. The mentor is like, no, this is wrong because of this, and you have this. But in the end, the student is becoming almost like a vessel, like a conduit. And at some point, the scientist may say, you know what? Why not I just put the things directly in my AI assistant and do this? And so I will get better results. It will be faster. I will do an entire summer of work in 12 hours. That kind of calculus is going to come along. And so we need to restructure. I really think that we need to restructure the undergraduates, research for undergraduates now, more aligned with the idea that the students are going to be using these machines.
It's a valid point. Do we have any lingering or final questions, thoughts, comments for Andres? I've done the 5-second pause you're required to do. All right. Thank you again, Andres, for your time, for your presentation. And yeah. All right. Well, we can move on to the next part of our agenda, which is looking at voting on some FEPs or PyHC enhancement proposals for those unfamiliar. I mentioned this on I almost said Monday, on Tuesday of this meeting. We're going to be voting on two different VEPs this time. One is a first vote and one is a second or final vote. We could probably go ahead and start with the one that's a second vote because I'm assuming that that should go a little more quickly. I would hope anyway. So let me pull that up if my internet decides to work. It's thinking. We're all processing slowly. It's almost Friday. All right. So again, FEP4 is the PyHC package tiering FEP view file. I already gave an overview of it again for anyone who might not have looked at it in a while this last Tuesday. There we go. But just as a quick reminder, it's the PyHC package tiering FEP. It's what's going to separate all of our FEPs out into either bronze, silver, or gold tier packages based on adherence to PyHC standards and so forth, with various benefits accruing at each level. And you can go through and see more of that here. So, again, standards compliance, as I mentioned on Tuesday, will be dependent on what's defined in the standards FEPs, one of which we're going to be voting on today. The others are in progress, and hopefully we can get wrapped up and voted on before the end of the year here. And then the benefits accrued include things like whether or not there will be an initial invite to present at our summer school series, how much help you'll get with standards compliance, where obviously the lower tiers are going to get more help trying to bump them up, whereas if you're already at gold, you are the standard, so you don't need as much help. PyHC chatbot inclusion and how much emphasis is placed on making sure all the data in there is as good as it can be. Same with PyHC environment or other related software environments. And should PyHC ever have open funding for conference travel to send some of our folks to relevant conferences and meetings, higher tiers would get priority and so forth. I can go through this a little further, or we can just go ahead and go. You all can see what I'm dealing with here. Back to the conversation. So since this is a second vote on the FEP, I believe what we'd agreed on previously is that we would do a GitHub pull request approval, where you can put it in as a comment. We've done that in the past. Let me put the link to this in the chat. Or, do we have any thoughts? Sorry, my voice today. Comments or questions before we get started on voting? And I've lost my window where you are all shown. There we go. If there are no thoughts, comments, any of that, go ahead and hop onto that link. Make sure you're logged into GitHub, put it in a comment, or just do a approval of this PR. I'll stop sharing my screen.
Yeah. I want to make sure that everyone has like the ability to hit approve on the PR. I think we've set our GitHub permissions to where it's just like totally public and anyone looking at it can do things, but
in theory, otherwise I think anyone could comment.
yeah, maybe if one of you all gets to the PR and you do not see an actual approve PR button, speak up, please, and we'll just note that. Do not see an actual review option for Joy. Ah. Well, then I guess I need to go back and relook at how I've configured the permissions there. But I guess we'll request, yeah, like Julie said, for anyone who can't actually give a formal approval or denial on the PR, just comment yay or nay, please.
Pretty sure I can't give an approval on my own PR.
I do not think you can either. I think as the author, we assume that you endorse it.
I'll put a comment. Give it a couple minutes for anyone that's still voting. I know we have a couple on the call that haven't. Just checking back in. Do we have anyone still working on voting, looking through the PR before voting? If we're all done, then I can put down that we had 8 on the call, 3 abstained, and go forth and prosper.
Yep, I guess so.
All right.
Um, I'll note, just for the sake of noting it, that this was one of the smaller voting pools that
Yeah,
we've had. But hopefully, the fact that we've been talking about this exact FEP4 for like 2 years means that most people have already given the input they wanted to give.
I believe so. I'd hope so by now.
Yeah. But this is our process here.
Yeah, it was
We
announced.
followed it.
Yeah. All right. Um, so naturally then we will move on to a second vote. Not second vote, the next vote for a first vote on Web 6. Link is now in the chat. So this is for the community and licensing standards FEP that John Niehoff so graciously spearheaded. Unfortunately, couldn't make it today, but put me in the lead for making sure a vote happened on it. So for a first vote, we don't comment on the GitHub, I believe. I think we just put in the chat here whether or not it's a yay or nay.
Yeah, and then I guess it'd be up to you, Julie, to copy those votes from the chat into like the spring meeting report.
Right. Um, I can give people a couple minutes too if you want to take a read through it if you haven't had much time to consider it. So let's give it up to 5-ish minutes from now. It's not too terribly long of a FEP. Hi, Nick. Thanks for showing up.
Thanks, everyone. See you soon. Bye.
And feel free at any point if, oh, perfect. Thanks, Jim. Um, if you are in approval of it, you can go ahead and put it in the chat. Joy, are you voting on this step? Are you still reading? I don't want to like cut you short or anything. Oh, okay, cool. Thank you. And Andres, I don't know if you are also participating in this or if you want to just consider yourself an abstained vote.
I am actually, I've never seen this process happen, so
Oh, cool. Well,
I'm
feel
just
free.
seeing it for the first time, but I'm not going to vote. I'm just
Okay.
curious.
Sure.
So please don't count me. Yeah. Oh, abstain, I guess you can.
I'll just for the proper terminology, we'll put abstain. But yeah, this is a new process that we implemented within, well, new I put in air quotes because it's been two-ish
Couple
years
years
now.
now.
Yeah. But I mean, we're still on the first handful of FEPs and pushing them through. The first couple went through pretty quickly. They were just describing this is what a FEP is, and here's a template for making a FEP. So those were the first to go through. But it's supposed to kind of mirror that Python enhancement proposal process or the PEPs. Just a more standardized way of pushing through standards changes, processes that we want to implement in the group, and so forth. Things to be more official, if you will.
I think it's so cool. I've always been fascinated and I'm very inspired by you guys. Like,
Aw.
Thank you.
so
Appreciate that vote of confidence. All right. Well, that concludes the FET voting. I put a lot of time on it originally because we were going to vote on more things for the first time. But John is but one human. So we can always put out that we're going to go vote on a FEP and then not vote on it, but we cannot do the inverse. So better to
yeah.
be safe than sorry, we figured. Um, I don't have wrap up slides this time around. I kind of just, I mean, maybe with the people here wanted to chat a bit. Obviously, goodness, I don't even know what number this is now for our biannual meetings. We're in the tens somewhere. Maybe this is like our 14th or something meeting we've had
Yeah.
since starting in 2018. I was hoping we'd have a bit of a bigger crowd, but maybe we can talk about that. Do folks have ideas for what they might want to see out of our meetings? What might draw in more participation? Are there things you're hoping for that you're not seeing happening? Are you liking the format that we've had? Just kind of hoping to source thoughts from the crowd and make the
Mhm.
next meeting a bit more lively.
Oops. I'm seeing the participants and we've lost quite a few of them. So I guess that question mainly goes to Jim or Joy, if either of you have thoughts on that.
I don't expect you to have the end all be all answer.
I'll definitely say that the topics you guys are moving along with how the field is moving, with all this new AI stuff, and seeing how you guys are implementing it into your own work, and then Andres's presentation. I mean, it's so rich and valuable. I'm almost sometimes surprised that most people aren't taking advantage of this open source information, especially Andres's presentation today. If there's one thing I've learned from making mistakes in my career is that English, in my opinion, is the most important subject everybody should definitely master, through middle school and high school, because it will literally lead the way. And him iterating that um, is really valuable. Um, I guess pointers, um, can't think of any. I know that Nick Murphy definitely pushes this meeting onto the CFA. We can definitely try to do that more within our heliophysics community.
Great.
Maybe, yeah. Can't really think of any more. I mean, you guys are definitely involved with meetings and conferences throughout the year.
Mhm.
Um, I'm not sure, but I'll definitely give it some thought. I know I'm trying to become more involved myself by
Yeah, that's
attending.
much appreciated.
Yeah, we appreciate your presence and thoughts.
Yeah.
It's just one thought that's sitting at the top of my head is that our community meetings like this have been pretty focused on like our, core PyHC packages, which there are just 7 of them.
Mhm.
So I think there is a chance that people have just kind of considered, their understanding of those packages a solved thing, and we're kind of beating a dead horse. But now that we have FEP4 coming in and packages are going to be moving into gold tiers and stuff, I think we might have an opportunity to include more than just the core packages or expand what the core package is, and then that might uh, be good for a broader audience.
That's true.
That's a
I
good
mean,
point.
this idea of core technically goes away. It would just be gold, silver, or bronze.
Yep.
Well, I'm wondering if it might drive more participation if we had a portion of the meeting that was uh, oriented more towards users and maybe uh, like a place, since we have the package maintainers gathered together, have some of the users show up and say, what would they like to see in some of these major packages, or what were some of the challenges they've had in using them or getting them to interoperate. And yeah, so like, less uh, uh, for those who maybe aren't so interested in governance stuff, but the practical applications, um, that might be a way to draw in more participants. And I mean I as a package maintainer, I would like to have some of that kind of feedback too.
Oh, yeah.
I was actually wondering exactly the same, even though, my understanding is very limited. But you could frame it a little. But I was thinking about when we did the Surya workshop, there was one day that was informational,
Hmm.
and so maybe that there could be something like that where there is a day, for example, you know, crazy idea. You could time this with a focus meeting at NSO, and it is like a focus meeting. It happens on a Friday. You know, you're going to have almost everybody, all the audience in NSO captive, and there is going to be people online that join this regularly, etc., etc., and you kind of like facilitate it and manage it in a way that addresses your goals, and you use it as an outreach or something like that. I don't know. This could happen just once per year or something like this, but it could be something where you are like directly in contact with users and you invite some of the use cases where you see interest within the team to present in the focus meeting and things like I don't know. Something like this could be um, that something that could bring more engagement, potentially even down the line, people that were not initially part of the core team get exposed to the concepts and things like that. And so you invite people explicitly for this. It gets advertised within the network, and so something like this.
Yep.
Yeah, no, that's all really valuable feedback, and my mind is kind of spinning the wheels a little bit on the user participation side of this because I really like that.
Yeah.
Just not developers of PyHC packages, but just users of PyHC packages, and that let you have a voice, or office hours or give feedback or some kind of thing. So I'll be thinking about that. And
Yeah, no, I mean, we've floated the idea of PyHC office hours before. It's just very dependent on our developers having the free time and cycles to do that, which not a lot of people have right now. So maybe having it focused instead at our biannual meeting where it's a very specific shorter time frame would be an easier ask of folks. Something to consider. I like the idea of a user workday or something where at least one of our days is just focused on that. We could have breakout rooms, people going and asking questions, and
The last thing I'll mention, I don't know if it's so much related to PyHC directly. I know you guys done something like this in the past where you guys invited a series of different packages, regardless of their size, and have them do like 5 to 10 minute presentations. I think those were helpful, not only because they change and update, but you get to see what's new to their work.
Definitely.
So I'm a big fan of that. I get to see what's the latest work on other packages as well.
Yeah, definitely. And I mean, in the past, I know we had more presentations than just core packages. A lot of it was like HDEE packages. Unfortunately, insert pointing around at our general environment. That funding has not produced a lot of projects in the last year or two. So we've suffered a bit for that, but I mean, we do still have, oh, thanks, Andres. It was great having you. But we do still have, packages already within PyHC that aren't core that we could focus on a bit more too. All right. Well, we don't need to beat a dead horse as the saying goes. Let me pull up my calendar to make sure I'm getting the day right. You can go ahead and end just a little early. So we just had the spring meeting this week. There'll be no PyHC Telecon next week. I know the last month or two, it's been pretty sparse anyway on telecons, just topics have not come to fruition. However, we for sure have one planned for, let me see, I believe it's June 1st. Yeah, June 1st. Angeline's finally going to get a chance to talk about her new package that she put into the community. Oof, what, 3-ish months or something like that ago now?
yeah, it has been a while, hasn't it?
It has, it has. And that's for Pi intensity features. So really excited to have her talk about it. I know she had to go through a process to get approval for it. So, woo.
Cool.
All right. Well, thank you, everyone. Sean and I were kind of chatting on the sidebar. We're probably going to keep some kind of asynchronous voting up for a little while. Maybe for the next 24 hours or something. I'll send out an email as soon as we wrap up here. And hopefully we can get some more thoughts and eyes on these PRs.
Thank you. Bye, everyone. Have a good one.
Thank you.